So here's the October 2025 paper, and I'm going to start the timer now. All right, let's go. Okay. Wait, let me move that a little bit. Okay. Okay, so number one. Well, arithmetic series start with that. Okay, seems like the terms decrease by 3, so it seems. So that means d is equal to 3. We want to find the 18th term. Well, that's fine because we just, let me increase the size here a little bit. Okay, so d is minus 3. So we're just going to use a 18th equal the first term, which is 78, plus n, which is 18 minus 1, times the common difference. Note that it is minus 3, not 3. Got to be careful with that. So it's 78. So this is 17 times minus 3. So calculator will do. 78 plus 17 times minus 3. Just that little times there. Okay, so that makes sense. 27. All right. So that's A18. Okay, so this is part A, part B. The sum of the first 100 terms of the series. Well, that's not bad because we just do S100 here, and we know the formula. We can plug in all numbers. So it is n over 2, if you look at the formula sheet. It should be 2 times the first term. I'm just going to maybe move that down here. Yeah, and then plus n, which is 100, minus 1 times the common difference again. Yeah, that's it. Or you can use a plus l, but we don't know the last term. L would be the last term, but we don't know it. So we're just going to use that formula there. And then we just plug in the calculator. So 100 over 2 is 50 times, in brackets, 2 times 78, which is the first term. Is it the first term? Yep. Plus, that would be 99 times minus 3. Checking everything, if I plugged in everything correctly. It should be. So minus 7050 there. Yeah? Okay, so that would be it. The first question, that's fine. Second question. The first 4 terms in ascending powers of x in the binomial expansion of that are that, right? Where p, q, r constants, find the value of p, the value of q, and the value of r. So we're just going to expand the first 4 terms. Okay, so basically I'm just going to write 1 plus px to the power of 10 equals, well, the first term is just 1 basically, 1 to the power of 10. The second term would be 10c1 and then 1 to the power of 9 px to the power of 1 plus 10c2 1 to the power of 8 px to the power of 2. I know 1 to the power of anything is 1, but we just write down to get some marks there, some working marks. And then the last one, 10c3 1 to the power of 7 times px to the power of 3. And that would be it, right? Yeah. And we just simplify each term. So 10c1 should be 10. 10 times 1 is 10. So this is 10px. And the third term, 10c2, well, if you plug in the calculator, you should get 45, sorry. So this thing here is 45. Yep, that should be right. 45 times 1 is 45. So 45 p squared x squared. And then the last term, oops, this is 7. Yeah. The last term, 10c3, well, 10 times 9 times 8. I'm just going to use a calculator for that one. So 10 times 9 times 8 divided by 3 times 2. Yeah, that's 120. So 120 times 1 times p to the power of 3, x to the power of 3. Okay, so that will be the last term. Now we just compare the coefficients. We see that p should be 15 equals 10p. So P should be equal to 15 over 10, which is 3 over 2. Okay? And then we compare the third term, 45P squared. So 45P squared equals Q. That means Q equals 45 times 3 over 2 squared, which is 9 over 4. I'm going to use a calculator for that. 45 times 9 over 4. That would be, okay, 405 over 4. We need to check on that, right? And then that would be Q. So that's Q there. I'm just going to rub this off. And then maybe move it to the left a little bit. Okay. Maybe that. And then R, well, R is 20 times P cubed. So 3 over 2 cubed. That would be 20 times 1.5 cubed. Yep. 405. Well, let's see if I made any mistake there, because you can't be too careless about this. I'm just going to check from the beginning. So 1 to 10, 10C1 is 10, 10P there, and then 10C2 is 49. Yep. 49P squared, and then, yeah, I think 10C3 is still 120. Yeah. Yeah. How do they do this? 10C3. Yeah, 120. And then I equate to compare the coefficients. So 10P equals 15. So I get P to be 3 over 2. That's fine. Q equals the x squared term, which is 49P squared. And I plugged in. Let's do the 49 times 9 over 4 again. Yeah. Let's do the same one. And then that should be alright. That is 120 times 1.5 cubed. Yep. I think I'm happy with all that. So this is all the answer. Next, question 3. Yeah. Okay, so we have part A, use logarithms to find the value of k to 2 decimal places. The value of k is the point P, so we just plug in. We use y equals, well, k is the x value, so y would be 300,000. There is no unit trick here, so just 300,000 equals 3 times 2 to the minus k, because the x value is the k. Alright, so we just solve for that. Basically, k would be equal to, well, we take the log 2 of, if you rearrange it, you get this, right, first, and then you take log 2, log base 2, I mean, yeah. Okay, so 300,000 divided by 3, and then you take log base 2, and then because that would be minus k, we put a minus here. Just solving the algebra, basically. You should be good at algebra. So minus log, how do I do log base 2? This there, log base 2 of, that would be 100,000. Yeah. So k is negative 16. We need to put it into 2 decimal places, but this is the way I would do it. I'm just going to do that and then round it to 2 decimal places. Yeah, like that. Yep, minus 16.61. Does that make sense? Yeah, it should go to the negative side, right? As you can see, the curve on the left-hand side, the y value is so high, so x should be negative. Yeah, makes sense. That's part A. Part B. Table shows corresponding values of x and y for y equals all that. So the values of y given in 3 decimal places were appropriate. Use trapezium. Okay, so it's basically that same equation there, that same function. And then we are integrating from minus 0.5 to 7 using the trapezium rule for approximation. So basically, this is going to be a long line. Yeah? So this 3 times 2 to the minus x dx is approximated to 1/2 times, so the width strip, the strip width is it's 1.5, yeah. So 1.5 times, big parentheses, we would sum up the first and the last term, the last y values, and then, 2 times all the other ones added up. So 1.5, the second one, the third one 0.53, the fourth one 0.188, and the fifth one 0.066, all that. Okay, I have limited space here, so. And then that would be the approximation. So we just put everything into a calculator. 0.5 times 1.5 times big parentheses 4.243 plus 0.023. Oops. 0.02. Ooh. The app just shut down for some reason. I need to open back up. Okay, that's bad. 0.5 times 1.5 times brackets 4.243 plus 0.023. Ooh, why did I? Yep. Then plus 2 times bracket. I'm just going to do that first to avoid misplacing brackets. Yeah. And then we have to put the other ones inside 1.5 plus. I'm just going to do this. Yeah. So I can see from the table again, 0.53 plus 0.188 plus, just checking the display there, 0.066. That's it, right? Yeah. Okay, I think I'm happy with all that. Just the input there, you gotta be careful. And that gives me 6.6255, which is 6.63, the 2 decimal places. Is that 2 decimal places? Yep. There you go. And then part C, right? Use your answer to part BI to estimate this. Well, it sort of seems like one of the term is the same power, but taking the 3 out. And the other one is a flip, right? Because, okay, so this one is going to be, yeah, the original one divided by 3, right? So you're just going to take the 6.6255, I'm going to take the more precise number, divide by 3. Because the one we had before from the trapezium approximation is just 3 times. So we divide by 3 to get just 2 to the minus x, the integral of that. And the other one here, ooh, look at that, it's a flip, isn't it? So you flip the coordinates there. Let me think about it. So how'd you get that? So the original is 2 to the minus x. If you flip, okay. So for example, if this were 3 times 2 to the minus x, so this would be the original, right? And that would cut probably at 3 here. This is the fx. This is y equals 3 times 2 to the minus x, yeah? But then that one, right? Okay, ignoring the 3 for now, only taking into account the 2 to the minus x, so because they flip from negative power to positive power, you would get, so this would be the graph of 2 to the x. A little bit lower because there is no multiple of 3 there, right? And basically they swap the limits as well. So it's like, it's kind of like the same area, right? So it's like this. If it was just 2 to the x here, well, let me just draw the original. So let's say this is 2 to the minus x, and you take the limits of 0.5 to, let's say 7 is around here, and the area would be underneath that, right? The integral. But when you flip to the other side, this would be 2 to the x. And then what? You see, if you flip the limits, it matches perfectly with the original. because then minus 7 would be on the other side, on the other tail of the exponential curve, and 0.5 would be on the other side. And then if you integrate for the area, you get the exact same area, right? So that means this particular area would be the same as the integral of 2 to the minus x dx, integrating from minus 0.5 to 7. And that happens to be the one we got above here, right? That means, I'm just going to write some rationale here. So minus that, 2 to the x dx is equal to the integral of, you flip, minus 0.5, 7, 2 to the minus x dx from the, diagram below that. That means this is basically just that same thing up there, because we already got it. That means ultimately the answer to this question would just be 2 times whatever that number is, right? So therefore the blah 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 equals, so I'm just going to write equals, the integral of that equals 2 times that. Okay, so I'm just going to do 2 times 6.6 255 divided by 3. And that should give me 4.417. So because it's 2 decimal places, so I'm going to keep 2 decimal places. So 4.417 or 4.42. That's it. That's done. Yeah? That should be fine. 2/3. Yep. So that's part B. Wait, that's not part C. It's part BII. Sorry. This is part BI. This is BII. Okay. And then number 4. Part A, when f(x) is divided by that, the remainder is r and the quotient is qx. Right. So we might have to do long division here, because they want the quotient as well. So the quotient is the product of the, like what you get from division, like on top if you do long division. So let's do it. 4x cubed plus 13x squared minus 10x plus 8. You got to be careful that all the terms are actually in the descending order. If there are missing terms, then you just basically add dummy terms like 0, x, or whatever. Yeah. And then we divide by x minus 2 there. So, well, x minus 2, we're just going to divide the first term into the first term. We get 4x squared there. So this will be, of course, cancelling with the top one, and then you multiply back, so you get minus 8x squared. You subtract. Of course, the first one will be 0, but the second one will be 13x squared minus minus. Careful, yeah? People make this mistake all the time, confused about the sign. So 13 minus 8 would be 21x squared. And then you bring down the next term, which is 10x. And of course, we divide the first one into the first one, so that gives me plus 21x, right? And the sense should be, they have descending order of the power of x, right? And then, of course, again, the first one should cancel. And then the second one, minus 21 times minus 2 is minus 42x. Yeah, subtract. Minus 10 minus minus 42. So that's minus 10 plus 42. So that is 32. Yep. And then bring down the last one. And repeat the process. So first term dividing into the first term, we get 32. And then 32x here. Minus 32 times minus 2 would be minus 64. We subtract again. So that would give us the remainder of 8 minus minus 64 would be plus 72, yeah, as the remainder. I'm just checking the math. So part I, qx is basically 4x squared plus 21x plus 32 and R is just 72. Yeah, part A there. I think it's fine. Just checking quickly that if I got everything okay. I mean, copying the question is also important. People make mistakes all the time on that, from my experience. Yeah. I think I'm happy with that. So part B. Part B, I use the factor theorem to show that x plus 4 is a factor of that. Well, factor theorem says that we can just do f and then minus 4 to see if it gives me 0. So we just substitute minus 4 into the expression. Minus 4 squared. I'm just going to do the next line here. That's it. So if we do a calculator there, 4 times, that would be minus 64, plus 13 times, that would be 16, that would be 40, and that would be 8. Ooh, 8. Yep, it does. So, therefore, x plus 4 is a factor of fx. It's just a no-brainer part here, but you just have to write. Whatever a math question asks you to show, usually they want you to repeat that is true. Yeah, just like that. Part I. Hence proved using algebra that the equation fx equals 0 has only one real solution. Use algebra again. Maybe long division again. We need to divide again and then show that the other quadratic factor doesn't give any solution. Yeah. I'm just going to do it differently here because I showed you how to do long division. So I'm just going to do like, so we know that x plus 4 is a factor. We come up with another general form of quadratic, and then we put that to 0, like that. Yeah? Well, hang on. I'm just going to maybe shrink down here. And I'm just going to bring the original expression first, which is the fx, of course. There. Now it means that for C, right, if we compare the last term, the only pair of products, the only product that would give the constant term here would come from 4 times C. So 4 times C must be 8, so C is 2, right? There you go. And if we do the same thing, so this is another way that I mentioned, yeah? So you could do long division. If the question doesn't ask you to say, get the remainder or anything, I mean, doing like this would ensure that you get the factor also, like quadratic factor. But it's just another way. Long division also do here. Yeah. And you can see that A must be 4 because the only combination would be that times that, right? So that would give us 4x cubed. So 4 is equal to A, or A is equal to 4, right? And then for B, we can take the second degree or the first degree. Let's do second. So the second here, the pair that would give me x squared would be that and that, right? So that is 4a plus b is equal to, the second degree is 13, the coefficient. That means b equals 13 minus 4a, which is that, yeah? So it's minus 3, isn't it? 16, 13 minus 16. So that means x plus 4 times a is 4, x squared minus 3x plus 2 would be equal to 0. I'm just checking everything. 16 minus 3, yeah. Let's check the first order. Minus 3 no, minus 12 and 2. That's minus 10, yeah, that's right. So I'm happy with that. And then we check the discriminant of the quadratic because if we aim to show that there is only one real solution, which must be from the x plus 4, so the quadratic factor does not have any real solution. That means we just do discriminant. Alright, so b squared minus 3 squared minus 4 times a times c is equal to 9 minus, well, that must be more than 9, right? That's 32. And this is less than 0, right? Well, I'm just going to write down the value as well. So equals minus 23, right? Yeah. And less than 0. So discriminant being less than 0, no real solution. That means, yeah, fx equals 0 has only one solution, which is x equals, what is that? Minus 4. Yep. Sorry. Part C, yeah. Find the range of values of x for which fx is decreasing. So fx decreasing means that the derivative is less than 0. The gradient is less than 0. If the gradient is greater than 0, then it's increasing. All right. So we need to differentiate first. That would be 12x squared. I'm just differentiating the expression here. Yeah. 12x squared plus 26x minus 10. You guys can all do that, right? I'm just checking. Yep. And then we put that to greater than 0. Wait, decreasing, sorry, less than 0. So 12x squared plus 26x minus 10 less than 0. And then we find a solution for this. Seems like we can factorize, hopefully. I'm just going to try to factorize first, see if I can. And then 5 and 2, so 5, 15, 2, 8 doesn't work. Yep, 5 and 2 here work. So that should be minus, wait, did I get, I mean, no, that won't work because we need to get 26. Oh, okay, so 10 here and 1 here. Yep, that would be 30 minus 4, which is 26. And we get minus 10. Yeah. So that means if we do the quadratic process here for inequality, the critical value here is 1/3, and here is minus 10 over 4, which is minus 5 over 2. We plot them, right, in the line, in the number line. And then because it's a less than sign, so if it's a less than sign, you take the range in between the two critical values. If it's a greater than sign, you take the ranges outside these two values. So we take this, shown by the number line there, yeah, okay. That means the answer should be the range of values, yeah. We don't include the critical values because it's a less than sign, it's not a less than equal. Yeah, okay, so I'm just going to do that. There you go. That would be the answer, all right? Number 5, 28 passed now, guys. I think we are fine, just kind of halfway here. Trigonometry, giving any non-exact answers to one decimal place. Okay, we have that equation there. The range of theta is 0 to 360, so that should be fine because theta is just a normal expression there. There is no modification. That should be fine. So 5i. So I'm just gonna maybe change tan to sine over cos, like that. Plus 5 sine theta equals 0, right? And, I mean, you can multiply cosine to all the terms. So we get that for the first term, multiplying cosine, so it cancels. But this one we got sine theta cos theta here equals 0. Because cos multiplies 0, you get the same thing. And we factorize sine out. Note that you do not cancel sine theta on both sides because you're going to omit the solutions from the sine theta equals 0. So inside would be 4 plus 5 cos theta equals 0. So we got two sets here, sine theta equals 0. And 4 plus 5 cos theta equals 0. Two sets of solutions. Gotta be careful there. I don't need to modify the domain of the theta, so I'm good here. So theta is, well, what sine theta, what angle theta gives 0 for sine? It's 0, well, but we don't have 0 there, so it's 180 instead, and 360, right? Sine of what angle gives 0, you can just check. You don't need to use a CAS diagram for this one. But this one might do, so cos theta equals minus 4 over 5, so I'm just going to find the basic angle first. So basic angle alpha, the principal angle. So for those of you who don't know what I'm talking about, you should check out the CAS diagram video right there, yeah? Just go check it out and you will understand how to use a CAS diagram properly to solve this kind of question. Okay, so I'm just going to change that to a positive 4 over 5 and find the principal angle. That's what I call it, or anyone else would call it. So check if this is in a degree. It should be, yeah. Let me just check sine 30, yeah. If it gives me 0.5, then it should be. So cosine 4 over 5. So the theta, the principal angle is 36.869897, blah, blah, blah. Okay. I'm not gonna, I'm not gonna clear that. So I'm just, wait, what? Sorry. Oh, I did clear that. Never mind. I'm fine with that. Then we consider the CAS diagram, right? So in the CAS diagram, this is a cos of a negative value. So we take these two. Okay? And we would just find the angle sweeping from the positive x. That's one angle there. So it's more than 90 is an obtuse angle. And this one would be a reflex angle there. All right? So one of them would be pi minus alpha, and the other one would be pi, or not pi, sorry, 180, because they do degrees here. And the other one would be 180 plus alpha, right? So those are the two solutions from cos equal minus 4 over 5. All right? So what I'm going to do is just 180 minus, wait, what? 180 minus arc cos 4 over 5, like that. Yeah? So that gives me 143 point, any non-exact to 1 decimal. So I'm just going to do that. Or, well, it's easy to just change to a plus like that when you already have everything into place. 0.9, right? So 143.1 and 216.9. I'm just going to check again. Yep, everything is fine. I didn't copy it incorrectly. And so the solution is then 180, 360, 143.1 and 216.9. All of that. Part II. Solve for 0 to less than x less than pi the equation that. Well, my instinct tells me that I should cross multiply to see what happens. I mean, I don't know. I don't know what's going to happen, right? But it feels like if we cross multiply here, like this, yeah, you're going to get what here? The identity on top. And this is just sin x cos x equals 5 over cos x, right? Now, note that we can't cancel the cos here. If you think that you should multiply cos x on both sides to cancel the denominator cos x there, don't do it just yet. Keep it, because again, it might contain some answer. It might, right? So the top bit would be 1 divided by sin x cos x equals 5 over cos x, in this case. Well, it sort of seems like I have to take that back, because cos x equals 0 cannot be here, because cos x cannot be 0. So it seems like we can cancel them. Yeah, in this case we can. But if cos x was on top as a numerator on both sides, then we shouldn't, because it will contain cos x equals 0. So here we can cancel cos x, and then we get, if we make sin x the subject, we get sin x equals 1 over 5. yeah, and then we solve. So that's easy because the range is just 0 to pi, so that means x equals arc sine 1 over 5, and the solution should just be a single value because, oh, 2 actually, 2 of them. So that is, so I'm just going to change that to radian there, and arc sine 1 over 5. So that is, so x is 0.201357, blah, 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 or if we do pi minus that, right? Because again, the CAS diagram sign would be these two. So you will get that angle and that angle right there. So the other one would be pi minus the principal angle. Again, if you don't know what I'm talking about, I suggest you go check out that video quickly. All right. And yeah, so these are the two answers. So x equals 0.201 and 2.9, three significant figures, 94. All right, that's it. Number 6, circle equation. The points A and B lie on the circle C1 as shown. Given that A and B is a diameter, AB is the diameter of circle C1. Find the equation. Well, easy peasy. We just find the midpoint, which will become the center, and the mid distance between AB would be the radius, right? So midpoint, we do, so HK, which is the center, would be minus 2 plus 14 divided by 2. Yeah, add them up and divide by 2. Oop, comma, 18 plus 6 divided by 2, like that. So that is the center HK. So minus 2 plus 14 is 12. 12 divided by 2 is 6. And then 24 divided by 2 is 12 there. And then the radius would be, you can use the distance from the center, but I'm just going to do diameter here, which is the square root of, minus 2 minus 14 squared plus 18 minus 6 squared. Yeah, and then r is half of that. Square root of that would be minus 16, so I'm just going to do 16 squared here because it's the same thing. And that would be 12, so 12 squared. And that gives me 20. So r is 10, yeah? Or 20 divided by 2, of course. That means the circle equation would be x minus 6 squared plus y minus 12 squared equals 100. That's done. Part B. The circle C2 has its center at the origin, given that C1, C2 touch. Interesting. Very interesting. Okay. So if we draw a rough proximity of C1, oh, we already have C1 there. Okay, C1 is like this, of course. And then C2 has the center at the origin, and C2 touches with C1. That means it's not a big circle here because it's just touching the other one. So it's just like that. Find a possible equation for C2. Well, you see, this is one way, and the other way would be touching with the, the other circle being inside. So this one is usually missed. Yeah, you might think that, okay, touching outside is one of them, but how do you get the other one? That is the other one. Yeah, the red one, all right? So there you go. Now, how do we get the equation? Well, it's basically x squared plus y squared equals r squared. So that means we need to find the radius, right? And the radius is just that guy there or this guy. And as you can see, it has to, so when you have two touching circles and you draw a line passing the two centers, I mean, basically the line drawn from one circumference to the other side of the circumference of the other circle, they pass the two centers and they are just the sum of the diameters of the two circles, right? So that means we can find, well, we can also find this distance here, which is, you can just find the Pythagoras. So let's say this is whatever point, but this is basically the center of the first circle, which was 6, 12, right? And if you subtract by the radius, of the big circle, you're going to get the radius of the small circle. So basically, I'm just going to find that length right there first. Let's call that r, yeah? So r is just square root of 6 squared plus 12 squared, which is square root of 6 squared plus 12 squared. That is 6 root 5, yeah? That means the radius, this is called R1 maybe, the radius of R, the small circle, would be, oh, hang on, no. This is distant. Okay, let me call it A or something, yeah? Just not to confuse you with the radius or anything. So the small radius, let's say R1, which is the little, the radius of the little circle there, would be 6 root 5 minus the radius of the bigger circle, which was 10, wasn't it? Yeah, this one, yeah? So minus 10. And the r of the red circle, the bigger one, the other case, would be, well, you have to add another r here for the big one to get the distance from the origin to the other edge of the circle there, right? So that would be 6 root 5 plus 10, right? So now you get 2 cases for the radius. The remaining part is just work out the r squared for this, right? And then you'll get the circle. So if you get, yeah, so r1 squared would be, do we need to put in exact form or what? Yeah, we have to assume that, I think. So it's, can I try this? I mean, I'm not sure, but I'm just going to try. Nah, it doesn't work. So it's basically just, if I square R1 first, I get 36 times 5 times 5, that is 180 plus 10. And for the minus, it would be 12 root 5. And I gotta get something, guys. I'll be back in a sec, yeah? Just 1 minute. Okay, I am back, sorry. So, where were we? So if we square the R1, we get this, which is 190 minus 12 root 5. That means if it was R2 squared, it would just be 190 plus 12 root 5. That means the equation, the 2 possible equations for C2 would be x squared plus y squared equals 190 plus 12 root 5, or x squared plus y squared equals 190 minus 12 root 5. That's it. Because, I mean, you minus 10 and, wait, hang on, plus 2 times, I made a silly mistake here. It should be 120, right? Yep, there you go. Okay, I'll write that again. So 6 root 5. I'm just going to do plus or minus squared there. It should be 36 times y is 180, but 10 squared is 100, so 280. Yeah? Yep. 180 plus 100, 280. And then 2 times 6 is 12. 12 times 10 is 120. So this is plus or minus 120 root 5. Yep. Just checking. And then we put that correspondingly. So 280 plus 120 root 5, or 280 minus that. That's it. That makes sense. Okay, so the 2 equations are found. But sort of gives me the sense that I might do it wrong or something. Because 6, 12, okay, let's do 6, 12 again. 6 and 12, so that should be fine. And the Pythagoras between 6 and 12 would be still 6 root 5, so I think I'm fine with that. Let's see. Number 7. Okay, it's 47 past now. Part A, find dy by dx in simplest form. That's fine. So we just can differentiate that. So that gives me 3x squared, yeah, for the first time, minus 4 times, well, I'm just going to do some working here, 4 times the power, and that is subtracted, and then half k, and then that is minus 1, and then 28. Simplest form would be 3x squared minus 4 cancel 2, I get 10, so 10x to the power of 3 over 2 minus 1 half k x to the power of minus 1 over 2 plus 28. That's it. Let's see if I made any mistakes there. I shouldn't be making any mistakes. Okay. Part B. The point T shown in figure 3 is a minimum stationary point. Okay. Given that x coordinate of T is 9. Right. Show that k equals 6. Right. So we just have to equate this to 0 and plug x in, yeah? So the derivative there that we found, we plug x equaling 9 in because it says that that is 9, okay? So if we plug 9 in, yeah, because the x coordinate of t is 9, we should get 0, right? Because the derivative equaling 0 means a turning point. And we leave k unknown here because we are finding it equals 0. Okay? So 9, yeah, maybe better use a calculator here. So 3 times 9 squared minus 10 times 9 to the power of, that is basically 1.5 plus 28. So basically this is 1 equal 1 on the left hand side. I push 1 half k, and that 9 to the power of minus 1 half is basically 1 over 9 to the half. So this is 1 over 3, right? Yeah. So basically k is equal to 6. Yeah. Just double checking here. Should be okay. Oh yeah, there you go, as shown. The line through T parallel to the x-axis meets the y-axis. The line through T parallel with the x-axis meets the y-axis, and the line segment NT. Okay, use algebraic integration to find the area of R. Interesting indeed. Never quite seen a question like this in P2 before. Okay. Let's explain this graph first. Note that T is a little bit further down from, this point here, y-intercepts. So make no mistake, if we integrate from 0 to T, we're going to get this negative area. Make no mistake. And that's fine, because we can subtract this area from this rectangle. Do you see the rectangle? Is this rectangle here? Yeah, is a rectangle, this rectangle here, yeah, see it? So if we subtract that negative area from the rectangle, we get the area we want exactly, R. Yeah? You need to interpret that first, alright? So this is 0 to 9, yeah? So that means R is equal to the rectangle. We need to find the y-coordinate first of that point T down there, right? Yeah, so this point T is 9 and whatever y is. So we need to plug 9 into the original function. Y at T would be equal to 9 cubed minus 4 times 9 to the power of 5 over 2 minus k was 6 there. 9 to the power of 1 half. Yeah. Wait, am I missing a term? No. That was confusing. Plus 28 times 9 minus 44. Got to be careful, so we're going to use a calculator. So 9 cubed minus 4 times 9 to the power of 5 over 2. Checking. Minus 9 times 6. Oh, that's 9 to the power of 9, square root 9 basically, yeah, which is 3, I shouldn't, yeah, plus 28 times 9 minus 44. Checking the input here if I plugged everything in correctly. I did. So minus 53, that makes sense, it should be negative. Okay. So the area of rectangle, yeah, the big rectangle that I mentioned, would be the base, the width, which is 9, times the height, which is 53, yeah? 9 times 53 would be 477. And then r would just be 477 minus the modulus value of the integral from 0 to 9. We know from the diagram that it's going to give us a negative value, right? Right? You agree? So I'm just going to change this to a plus because the area is negative, so you plus a negative value, and that means subtraction. Just make sure you understand this, right? Why I'm doing a plus here. Or I can say it's a minus and the absolute, yeah, maybe that's better. The function y dx, yeah, because as I mentioned, that shaded area is going to be a negative value if you obtain it from the integration. Okay. So, yeah, I can keep the absolute sign there. Integrating everything there, well, that's going to take some time because we're going to be thorough here. Well, you know what? I'm just going to integrate first and put everything back in. Like that. Yep. This k was 6 again. That's a minus 44 dx. All right. And then that would be x to the power of 4 over 4 minus, adding 1 would be 7 over 2, so that's 2 over 7, so that's 8 over 7. 2 over 7 times, yeah. Hang on. Yeah. X to the power of 7 over 2 minus, adding 1 would be 3 over 2, so 2 over 3 times that, so you get 4 x to the 3 over 2. Sorry. Yeah, I'm just checking. Plus 28x minus, wait, what? Wait, I must be missing an x here, yeah. Okay. That would be 14x squared then, yeah, minus 44x. And then putting the limits from 0 to 9. Expectedly, this should give us a negative value. So we can cancel all the 0 out, just putting in 9, right? So 9 to the 4 over 4 minus 7, 8 over 7, x. 9 to the 7 over 2 minus 4 times 9 to the power of 3 over 2 plus 14, 9 squared minus 44 times 9. Well, hopefully I didn't make any mistake there. 9 to the 4 divided by 4, and then minus 8 over 7, 7 times 9 to the power of 7 over 2 there, minus 4 times 9 to the power of 1.5 there, that's 3 over 2, plus 14 times 81, because that's 9 squared, and minus 44 times 9. Yep, negative as expected. Just checking the input here again. Yep, everything is fine. So I get minus 2 point that. So that means if we take the positive value, r, which is the area they want, is just that, which will become, if we take the answer, yeah, and 477 plus answer, yep, that should be the answer that we want. Looks fine, 247, and they want it in 3 significant figures. That should be 248 then. There you go. Okay, so that's it. That took some time, and I got half an hour left each. Let's do number 8. Geometric series has first term a in common ratio r. Prove that sum, well, you say lately they do this quite often now. You need to know how to prove for the sum of the series of both arithmetic and geometric, yeah? Okay, so because an is ar to the n minus 1, right? So that means Sn is equal to a plus ar plus ar squared plus until the last term, which is ar to the n minus 1, all right? If you multiply that by r, you get, I'm just going to shift the writing here so that you see what I'm doing, right? So if you take the top line, multiply each term by r, the first term, which is a, will become ar, which is the first term of r times Sn. Make sure you understand this because it's the critical step here. Plus, but then, you know, the second last term will be instead in a times r to the n minus 1, but the actual last term would be a r to the n. And if you subtract the two equations here, right, so Sn minus r Sn, everything will cancel except the first term from the Sn and the last term from the ar to the n. And because we subtract, so a must be minus ar to the n. Make sure you also understand this subtraction step. If we factorize Sn out, we get 1 minus r in here, and if we factorize a out, we get 1 minus r to the n in there. So if we make Sn the subject again, you find the formula, right, as required. There you go. Simple. At least I should have, yeah, I should make it simple for you. That's my job. The liquid is to be stored in a barrel. Due to evaporation, the volume of the liquid in the barrel at the end of each year is 8% less than the volume. That sounds like geometric, right? 8% less, like depreciation, so to speak, of the liquid in the barrel at the start of the year. At the start of the first year, the barrel is filled with 150 liters of liquid. Yeah? Show that the amount of the liquid in the barrel at the end of 6 years is approximately 91. Okay, so A is 150, then, yeah, this is basically just depreciation because it gets smaller and smaller. Yeah, so we find A6 basically. This is not the sum yet, it's just A6 because you keep multiplying by 0.8 to find whatever is left in the 8th year, right? So it's 150 times r is 92. Yeah, that is just 92% left. So the power of, at the start of the first year, you got to be careful here. That's tricky. At the start of the first year, because that is not the end of the first year, right? So if it was the start of the first year, then by the end of the first year, it is 150 times 0.8 already. So you're actually multiplying 0.8, not 5 times, because if you put here 6 minus 1, that would be multiplying 0.92 5 times, which is wrong because you are actually, it has to depreciate annually 6 times because the first year also counts. What would be the case that this works is that they say at the end of the first year instead. So this is where geometric series can be confusing for people. So I'm just going to do 7 minus 1 there, all right? Just to make it 6 basically. Or I can just explain to you that at the end of first year, yeah, A is equal to 150 times 0.92. We're going to get that first, which is 165.6. And then we plug in A6 equals 165.6 times 0.92 to the power of 6 minus 1. So it's like the first term isn't actually 150. Ooh, I made a mistake. It's 150, not 180. Yep, 138. Oh, that makes it a lot nicer. 150. 150. So this is 138. So 138 times 0.92 to the power of 6 minus 1, right? Is it 1.92? Yep. To the power of 5, guys. Yep. So that's 90.95 blah blah blah. I'm just gonna make that approximately 91,266 as required, of course. It's good that they tell you what to expect, right? So that you're not going off too much. At the start of each year, a new barrel is filled with 150 liters of the liquid, so that at the end of 40 years, there are 40 barrels containing the liquid. Yeah. Calculate the total amount of the liquid to the nearest liter in the 40 barrels at the end of 40 years. So, let me think of it. New barrel. A new barrel is filled. Okay. So it's like the first barrel from the first year will be filled on the first year at the start of each year. Okay. So barrel 1, you would start with 150. So this is, say, year 1. Yeah, and then it will go to something lower, like 138. But then in year 2, you have 138 for the start of year 2. And then the other barrel, 150. And then it would go like lower than 138, say 12 something. And then that 150 would be 138. And this keeps going, right? So we need to find the total amount of liquid to the nearest liter in the 40 barrels at the end of each 40 years. That looks like a sum, right? So let's say if you want to just sum up the total amount of liquid at the end of year 2, yeah? So that would be, 138 plus, it would be this, right? 138 plus, this is basically A2. So that would be, so at the end of second year would be, well, let's just find it, right? So 138 times 0.92, that's the end of second year for the first barrel is 126.96, but you have the first barrel being 138. So at the end of the second year, it's just the first two terms. At the end of the third year, right, let's just see the pattern here, just to make it clear. You would have these two, yeah? So you would have the first, at the beginning, 150 filled at the third tank, but it will have decreased to 138 as well. This one will decrease to 126.96, and the 126.96 will decrease to 24. That's amazing. Okay. Oh, I made a mistake again. That's that's too crazy. How can it be that fast, right? Blah blah blah. And this keeps going. So you see the pattern now that at the end of n year, it will just be the sum of Sn, geometrically, right? That means we just find S40, basically. And we have proved the formula, that's why they asked you to prove. But the first year is 138 again. R1 minus R, which is 0.92 to the power of 40, right? Divided by 1 minus 0.92. Okay. So fraction 138 times 1 minus 0.92 to the power of 40 here. And then divided by 1 minus 0.92. So that's 1663. The amount of, is it to the nearest integer? Is it say nearest liters? Yeah, okay. I'm just gonna do this first to show that I actually get the number, and then just round. So that would be that. There you go. Yeah, that's done. Next. I got about 20 minutes left. Oh, wait, what? I'm done. That's just 9 questions. Oh, no, sorry. Yeah, I forgot question 9. So I did question 8, and here's question 9. Well, easy peasy log equation. So part I, well, solving that, right? So by the looks, we just merge the logs. So that would become log base 3 of 4x plus 5, make the power like that first, and then because it's a minus, so we divide. Yeah, that's the argument when you combine everything, equals 2. And of course you can do 3 to the power on both sides, but my intuitive way of solving this is that because this is the base, so it will be the base. When you move to the other side, so to speak, the base of the log will be the base of the exponent. So basically you just, the 3 will become 3, which is the base of the power 2, like that. Yeah, you can do that. Now, it seems like we need to expand the quadratic, so 16x squared, 2 times 4 times 5 would be 40. X plus 25 equals 9 there, so 9x plus 27. Just solving that quickly there. So 16x squared plus 31x minus 2 equals 0. I'm just going to try factorize that. I'm going to go with 8x and 2x, see what happens. No, doesn't work. I probably need 16x because I see 31 in the middle. So maybe that's quite great. And it's plus 2 and minus 1 like this because we need plus 31x in the middle. So that works. So 1 over 16 and minus 2 here for the critical values. Yeah, or the answers actually in this case because it's an equation. Well, but we need to check always. Be careful, guys. If both of them work. If you substitute the negative, this bracket becomes a negative, right? So that doesn't work for the first one. Yeah, so we reject the minus 2 there. So x equals 1 over 16. Yeah, that's it. Given that a greater than 0, b greater than 0, okay, and that sort of seems like we have to prove from the algebra there. So from the first line we can merge the a and the b, we get ab here equals log 10 of a plus b. So that means ab equals a plus b. Do you see that? That means if we make a the subject, we move a from the right hand side to the left hand side, we factorize a out, and then we make a the subject. Bam, that's done. Alright? That's part A actually. Part B. Hence write down the full restriction on the value of B giving a reason for your answer. Full restriction of B. B cannot be 1. Because this is to avoid division of 0. Right? B cannot be 1. Can B be anything else? Can B be anything smaller than 1? So if B become anything smaller than 1, let's say 0.5, you see A would be negative. So actually B has to be greater than 1. So B has to be greater than 1 so that B over B minus 1 would be greater than 0, right? As A must be greater than 0, yeah? Okay, but B is not equal to 1 anyway, so B greater than 1 is enough just to write down. Can B be anything else? So if B tends to infinity, A will be 1, so that's fine. If B keeps increasing, A is still fine, like 100. If you put 100 in, it's 100 over 99, so that's fine. That's approaching 1, so that's perfectly fine. Log base 10 of that is that. Yeah. Well, just out of interest, if I try put in a equals 100, b would be what? If a equals if b is 100, just trying, if b is 100, a would be 100 over 99. So how do I get 1 actually? Yeah. A times b is not a plus b. If b is 100, a is that, and a times b is that, and a plus b is that, really? Ooh, interesting. So a times b is, that is a times b, basically, right? So ab is 10,000 divided by 99. But a plus b, 100 plus 100 over 99, what is it? Ooh, hang on. Oh, it's the same thing. Of course. Of course. So that's fine, right? That should be, because the algebra says so. I'm just checking. Sanity check, really. So that means b can be anything greater than 0. Greater than 1, sorry. Yep. B can approach infinity. B can be very large, no problem. And we already give the reason there. Because, so that b over b minus 1 is greater than 0. Yeah. I think I'm happy with that. What if b is super large? A is going to be 1. Log anything of 1 is 0. And that should be close. Yeah. Okay, I think I'm going to end this paper now and mark the paper. All right. Okay, guys, here's the mark scheme for the 2025 October P2. Let's go from the beginning. Question 1, of course. Yeah, that's 27. Yep, okay. I'm just going to assume that my working is okay, given the right answer. All right. So what are the P is 1.5. That is 400. Yeah, or equivalent. Yeah, I'm sure that is. Yep. Number 3, minus 16.61, 6.63, 4.42. Nailed it. 4a, 72 for the remainder. And that is the right function. Attempt a factor. Factorize. Yep. And then the right range down here. Okay. Number 5. These are all the answers. Yep, everything looks fine. And then 0.212, 92.94. Yep, that is the equation. Well, this one is right first, and then part B. And yeah, I didn't put, yeah, I could have put a square there, but yeah, I just expanded them, and I hope it's fine. It is, it should be fine. Yep, there you go. Plus and minus 280 plus or minus 120 root 5. Yep. Number 7, k equals 6, I showed it. Over the first one in the differentiation, hang on. 3x minus 10x, k blah blah blah, plus 28, yep. Part C, 2, 4, 8, good, well done base. Part 8, yeah, nailed it, the proof, of course. Yeah, that looks like the right answer. In 91, I proved it. And part question 9, 1 over 16 only. Yeah, okay, so part A, I proved it. and states either b greater than 1 as long as the x is positive number. Yeah. So I nailed it. 100 out of 100, as in either UMS or raw score. Okay.